Relating graphs to events. Now, graphs are going to be used to show a relationship between two variables. So, necessary skills that you need to have in order to work with a graph is the first thing you need to know: interpreting graphs, sketching graphs, and analyzing graphs. Let's look at the first one, interpreting graphs. Alright, so if I have a student walks and takes a bus to get from school to home each day, I want to describe what the graph below shows by labeling each part. Now, typically graphs, when you're relating events, it's over a period of time. So that's why I have time here. And then on my y-axis I have a total distance. So if I start out here, times 0 when I start my time, the first thing she does, she's going to walk. So the student's going to actually walk, and notice we're going over time, we're going adding to our distance, and that's why I have an increase here. And notice it's all the same rate too. Now, when I'm waiting for the bus right here, it's a flat line because you're not going anywhere, you're staying at one place. Though that would be where you'd be waiting for a bus. Now, riding the bus would be the steeper part of the graph because we all know a car or a bus travels faster than somebody walking, typically. So that's why in a certain amount of time, I'm going to travel faster and farther in distance than I did walking. So then here, you'll see this part of the graph, it becomes a little more flatter and less steep than the riding the bus. And this is the student walking again. And then I get to the point where I'm flat, and that will be when you're back home, when you're not going anywhere, we're not doing any distance. Let's look at the second one where we're sketching graphs. So a plane is flying from New York to London, and we need to sketch a graph of the plane's altitude during the flight. Then label each section. So we're doing it over time, and this time our y-axis is altitude. Now, when we're taking off in a plane, we start at the ground, which is like our 0 altitude. So that's why I start down here. And when you take off, you're increasing your altitude until you reach your cruising altitude that you stay at for the long period of time. So this section of my graph basically shows my takeoff and my increasing in altitude till you get to the flat part of the graph where it's my cruising speed, or where I'm spending most of my time in my altitude, where I'm not going to increase or decrease, I'm going to stay at one level. Then you descend right here. As you're preparing to land, you're starting to go down. Now, I typically, when I fly, I'm flying into Atlanta Airport, or I'm flying into Chicago to go home to Illinois. So we always have to circle the runway, the airport, waiting for our time to land. So if you're doing that, some planes actually will descend a little bit, get to an altitude where they have to wait, kind of do circles around the airport waiting for their chance to land. So that's why I put this little flat line here, saying that, you know, we're staying at the same altitude. And then you go all the way back down when you actually land the plane. You're going from that cruising altitude down to your 0 or your ground level. And that's where you've landed on the runway. Okay, the last one is analyzing a graph. So I have a situation. The car travels at a steady speed. Which graph could you use to show the speed of the car, and which one to show the distance it has traveled? Now, when we're showing distance traveled, typically you increase your distance as you travel over time. You're constantly increasing it. So I would pick this one for my distance traveled, or my total distance. Because it increases over time. My distance will change. So on my y-axis, I'm going to have distance. Now, to show the speed of the car, notice it is a steady speed. It doesn't increase, it doesn't decrease, it just stays the same. So this graph shows something that stays the same over time. So this first graph is going to be the speed of the car. And my y-axis for that one is going to be speed. Since it does not increase or decrease, it's staying steady.